Hello everyone. Today we will study the determination of the connection group numbers for Y-Y connections in three-phase transformers. In this session, we will understand and master the content from two main aspects. The content that needs to be mastered. 1. Master the determination of the Y-Y connection group with the starting terminals as like terminals. 2. Master the determination of the Y-Y connection group with the starting terminals as unlike terminals. First, let's look at the determination of the Y-Y connection group with the starting terminals as like terminals. When determining the connection group of a transformer, the electromotive force of the transformer is usually used to draw the phasor diagram. First, draw the phasor diagram of the high voltage side. According to the symmetry of the power supply electromotive force, first, draw an equilateral triangle. Find the centroid of the triangle. The lines from the centroid to each vertex of the triangle are the corresponding phase electromotive forces. The three sides of the equilateral triangle are the line electromotive forces. This geometric relationship satisfies the condition in the star connection circuit, where the line electromotive force is 3 times the phase electromotive force. The direction of the phase electromotive force points to the centroid. The direction of the line electromotive force follows the order of the letters, such as the direction of EAB from point A to point B. Remember, as long as the high voltage side is a star connection, this equilateral triangle is fixed. To define the clock method, the side AB of the triangle is usually placed in the vertical position. This represents the minute hand of the clock. After completing the phasor diagram of the high voltage side, draw the phasor diagram of the low voltage side. The low voltage side must first draw the phasor diagram of phase A. Note that the two coils of the high and low voltage sides, aligned up and down, must be on the same core column. The two coils on the same core column must have phase electromotive forces that are either in phase or out of phase. These criteria for judgment are 1. If the starting terminals are like terminals, the phase electromotive forces on the high and low voltage sides are in phase. 2. If the starting terminals are unlike terminals, the phase electromotive forces on the high and low voltage sides are out of phase. According to the judgment criteria and considering the connection method and the like terminal signs in the circuit, it can be known that phase A on the low voltage side is in phase with phase A on the high voltage side. Similarly, phases B and C on the low voltage side are in phase with phases B and C on the high voltage side, respectively. For convenience of comparison, first align the lowercase a with the capital A. Draw a parallel line to phase A on the high voltage side through point A in the same direction. It is obvious that the phasor of phase A on the low voltage side overlaps with that on the high voltage side. The neutral point N must be on the large AN. Next, draw the phasor diagrams of phases B and C. They should be drawn from the neutral point N on the low voltage side, with parallel lines to the corresponding high voltage side. When drawing the phasor of phase B on the low voltage side, a parallel line to phase B on the high voltage side should be drawn through point N in the same direction. Point B must be on the large AB. The same applies to phase C. As shown in white in the right figure, in short, as long as the low voltage side is the star connection. The phasor diagram of phase A should be drawn from point A. The phasor diagrams of phases B and C should be drawn from the neutral point N. After completing the phasor diagrams of the low voltage side, connect the straight vertex A, B, C from an equilateral triangle, which is the line electromotive force of the low voltage side. Then, compare the phase difference between the high voltage side line electromotive force EAB and the low voltage side line electromotive force EAB. Dividing the phase difference by 30 gives the group number of the winding. It is obvious that the phase difference of this connection method is 0 degrees. So, the group number is 0. Based on the previous case, if the high voltage winding remains unchanged and the low voltage winding phases A, B, and C each move one position to the right, as shown in the right figure, then phase C on the low voltage side is on the same chord column as phase A on the high voltage side. Since the starting terminals are like terminals, phase C on the low voltage side and phase A on the high voltage side are in phase. Similarly, phase A on the low voltage side is in phase with the phase electromotive force of phase B. On the high voltage side, the phase electromotive force of phase B on the low voltage side is in phase with that of phase C on the high voltage side. At this time, the triangle on the high voltage side is drawn the same way as before. The phasor diagram of the low voltage side is drawn by aligning the capital A with the lowercase a. Draw a parallel line to phase B on the high voltage side through point A in the same direction. This is the phasor diagram of phase A on the low voltage side. Next, draw a parallel line to phase C on the high voltage side through the centroid N in the same direction, which is phasor diagram of phase B on the low voltage side. At the same time, draw a parallel line to phase A on the high voltage side through the centroid N in the same direction as phase A, which is the phasor diagram of phase C on the low voltage side. The phasor diagram is shown in white in the figure. Connect points A, B, C to form an equilateral triangle. Compare the phase difference between the line electromotive force EAB on the high voltage side and the line electromotive force EAB on the low voltage side. The phase difference is 120 degrees. Dividing the phase difference by 30 gives the connection group number. The connection group of the three-phase transformer at this time is YY4. Based on the previous case, move the low voltage winding, phases A, B, and C, each one more position to the right, as shown in the right wiring diagram. At this time, phase B on the low voltage side is on the same chord column as phase A on the high voltage side. Since the starting terminals are like terminals, phase B on the low voltage side is in phase with phase A on the high voltage side. Similarly, phase C on the low voltage side is in phase with the phase electromotive force of phase B on the high voltage side. Phase A on the low voltage side is in phase with the phase electromotive force of phase C on the high voltage side. Similarly, the triangle on the high voltage side remains unchanged, and the phase electromotive forces on the low voltage side are drawn as follows. 1. Align the capital A with the lowercase a. Draw a parallel line to phase C on the high voltage side through point A in the same direction. This is a phasor diagram of phase A on the low voltage side. 2. Draw a parallel line to phase A on the high voltage side through the centroid N in the same direction. This is a phasor diagram of phase B on the low voltage side. 3. Draw a parallel line to phase B on the high voltage side through the centroid N in the same direction. This is a phasor diagram of phase C on the low voltage side. The phasor diagrams are shown in white. After completing the phase electromotive forces, connect points A, B, and C to form the line electromotive force of the low voltage side. This is a line electromotive force of the low voltage side, according to the phasor diagram. The phase difference between the phase electromotive force EAB on the low voltage side and the phase electromotive force EAB on the low voltage side is 240 degrees. Therefore, the connection group number of the triangle at this time is YY8. 2. Determination of the connection group number for star-star connections with unlike terminals. Unlike the previous case, the starting terminals on the high and low voltage sides are no longer like terminals, but unlike terminals. From the wiring diagram, it can be seen that phase A on the high voltage side is on the same chord column as phase A on the low voltage side, and the starting terminals are unlike terminals. This indicates that the phase electromotive force of phase A on the high voltage side is out of phase with that of phase A on the low voltage side, and the phase applies to the other two phases. First, the phasor diagram of the high voltage side remains unchanged. The corresponding phase electromotive forces on the low voltage side can be drawn based on the phase electromotive forces of the high voltage side. Similarly, align the capital A with the lowercase a. Draw a parallel line to phase A on the high voltage side through point A, but in the opposite direction. Do the same for the other two phases. The two diagrams are shown in white in the right figure. After completing the phase electromotive forces, connect points A, B, and C. According to the phasor diagram, the line electromotive forces on the high and low voltage sides are out of phase. This angle between EAB and EAB on the low voltage side is 180 degrees. Therefore, the connection group number is determined to be 6. So, the connection group of the three-phase transformer is YY6. Similarly, if the high voltage winding remains unchanged and the low voltage winding, phases A, B, and C each move one position to the right, as shown in the right figure, then phase C on the low voltage side is on the same chord column as phase A on the high voltage side. Phase A on the low voltage side is on the same chord column as phase B on the high voltage side. Phase B on the low voltage side is on the same chord column as phase C on the high voltage side. The original triangle remains unchanged. The relationship between the primary and secondary side is that the phase electromotive force of phase A on the high voltage side is out of phase with that of phase C on the low voltage side. The phase electromotive force of phase B on the high voltage side is out of phase with that of phase A on the low voltage side. The phase electromotive force of phase C on the high voltage side is out of phase with that of phase B on the low voltage side. The drawing is the same as before and will not be repeated. According to the phasor diagram, the angle between EAB on the high voltage side and EAB on the low voltage side is 300 degrees. Therefore, it can be determined that the connection group of the three-phase transformer is YY10. Based on the previous case, if the high and low voltage windings remain unchanged, and the low voltage winding faces A, B, and C each move one position to the right, and the low voltage winding faces A, B, and C each move one position to the right. As shown in the right wiring diagram, the relationship between the primary and secondary sides that the phase electromotive force of phase A on the high voltage side is out of phase with that of phase B on the low voltage side. The phase electromotive force of phase B on the high voltage side is out of phase with that of phase C on the low voltage side. At the same time, the phase electromotive force of phase C on the high voltage side is out of phase with that of phase A on the low voltage side. According to the circuit diagram, the angle between the line electromotive forces on the high and low voltage sides is 60 degrees. Therefore, the connection group of the three-phase transformer is YY2. Summarizing the previous analysis, we come to the following conclusion. 1. When the connection methods of the high and low voltage sides are the same in YY connected transformers, the group numbers can be 0, 2, 4, 6, 8, or 10, i.e., even numbers. This conclusion is used to judge the correctness of our analysis results. O. When the phase number of the high voltage side remains unchanged and the phase number of the low voltage side moves one position to the right, the connection group number increases by 4. In this lesson, we mainly introduced the determination of the connection group numbers for YY connected three-phase transformers. This includes two aspects: the cases where the starting terminals on the high and low voltage sides are like terminals, and unlike terminals. Okay, that's all for this section. Thank you, everyone.